So kiddos just joining us, it's chapel day, and we're kind of short on time because we were hanging out a little bit at the beginning of class. So we're going to grade 5.2 tomorrow, not today. But we're not going to totally jump into section 5.3 either. We're going to go ahead and finish 5.2 first. All right, my crazy talkers. This was the example that we were ending with on Friday. So we're in our notes, quickly finishing the final example from 5.2. It might help on some of the ones that you got stuck on. And I don't think 5.2 homework was super long, was it? No. Okay. So it was more concept-y, seeing if you guys could follow along with what was going on. So let's go ahead and quickly finish this example about polonium-210. That is, half-life. Is it growing or decaying? Half-life. Is it growing or decaying? Decaying. My chem people, I don't think you memorized two different formulas for growth and decay as far as the constant. So let me just quickly, because what I showed you was if we had plugged in for our formula of y of t, we knew our initial, we were able to go ahead and plug in 10. And then we plugged in half-life, which remember we could have gone ahead and set this equal to 5. And then divided by the 10. We've also been talking a lot about ratios. If it's half-life, then the ratio of what you have to what you had is 50% or 1/2. If you solved ln of both sides in division, you would have gotten this. However, another way of writing this could be k is equal to, can't I move numbers in front to be powers? So this could be the same thing as 1 over 140 times ln of 2. Oh, there's that ln of 2. Anyway, you could have memorized, because 1/2 to the negative 1. 1/2 to the negative 1 is 2. So you could have memorized that for doubling or for half-life, you do 1 over the amount of time it takes times ln of 2. However, remember, our goal isn't ultimately for the AP just to memorize a lot of stuff, which is why, one more time, we are not making this yellow box a forever card, because the AP is not going to give us, here we go, is not going to give us problems where we can jump to the final answer without integrating. So it's not going to be as nice as these problems. But why am I talking about these problems? They're in our homework. They're in our book, and any college class would talk about growth and decay because it's super applicable to lots of different fields. Yeah, population, and anyway, in econ and in chemistry and in microbiology, and anyway. So what's going on with letter C? Wait, did we finish? We basically did. We ended up with, just so we can use it in letter C, y of t is equal to 10e to the 1 over 140 ln of 2t. Is that right? Okay. Wait, pause. That was my k, right? And my k gets plugged in, with a negative. Oops, wrong way. There we go.
Wait, if you made it,
K. K got plugged in. Because for exponential decay, we had to plug it in. Yeah, so the negative went up and it was ln of 2, but then we still had to plug in the formula with a negative. Okay, guys, just reading the problem. That's what I'm trying to see. Can you read and figure out what you've been given and where to put it? How many milligrams will be present after 10 weeks? Time. Good. T is equal to? No. 70 days. Yeah? So we would go ahead and we would find y of 70 just by plugging and chugging. Guys, these are definitely calculator problems. Do it by hand. No. I mean, you could. 70 over 140 is 2, negative 2. It'd be ln of, actually, we could. Forget that. Who needs a calculator? Thank you, Nathan, for the inspiration.
Will they ever make us do
10
unit for this?
e to the negative 2 ln of 2. Yeah, milligrams, see? We can put this negative 2 up as a power. So that'd be 10 e to the ln of 1, because it'd be 2 to the negative 2, which would be 1/4. And then e and ln cancel, and then 10 over 4, because it's 10 times 1/4, ends up being 5/2, or 2.5 milligrams. Look at us. Psh, we didn't need a calculator. Go, team. Ooh. Ooh. Wait. Isn't
plugging in for T and then
in that box? That's not a forever card. Didn't we say percentage remaining? So Tyler's already figured it out, but let's try to follow along with what he's doing. If there's 70% that's decayed, what will I set my ratio or my percentage remaining equal to? Not 70. Careful. That's what decayed. What's left? 30% remaining. Right? So I'm going to set my ratio, which is y of t all over y sub naught, equal to 0.3 equal to e to the, what was it, 1 over 140? So remember, in that nice little card, which will be helpful for the test, 70% has decayed, which means only 30% is left. And in that forever card, we said percentage remaining. We can set the percentage as a decimal equal to the ratio, which is only that remaining piece. At which point we would take ln of both sides, right? Yeah. Do some multiplication. We'd end up with ln of 0.3 times negative 140 all over ln of 2. And it'll be in days. Double check math. ln of 0.3 multiplied by negative 140. Divide by ln of 2, and then t is by itself. Okay, with that, we're done. Kiddos, for homework that was over the weekend, not we're done, but we're done with that section. With homework that was assigned over the weekend, were there any particular problems you want me to get ready for now that you already know you have a question on? Yes. Which numbers? 56? 56 and 41. 41 was an odd, 56 is an even. Oh no. Poor Sam. Sarah's like, oh stink. Sam, we're supposed to have a mission meeting today, kiddo. Yeah. Okay, for those of you guys, I think that I heard 3 different questions from the homework over the weekend. Why don't you just take a second, look at it tonight, see if you can get a little bit further. I know the odds, wrong one, bud. I know the odds you were able to check and you still got stuck on, so we can talk about why it is what it is. But remember that it's not a forever card, but the box from the notes really does help in that each of these exponential growth and decay, you were able to make some jumps in how, and so it might look like they made some big jumps, but maybe they were just using the formulas that we talked about on Friday. You guys are going ahead and opening up section 5.3 notes and starting. Ironically, the notes are not very long on 5.3. Doesn't mean the problems are easy. They're actually super important. Just because they're important doesn't mean they're hard, but they can get tricky. Yeah, very true. I mean, slope fields are definitely some multiple choicey things, and we saw a lot of those examples, but 5.2 and 5.3, 5.2 is kind of word problem-ish, right? And 5.3 is definitely an FRQ sort of thing, so. Yeah. Better. Explanation's almost always somehow tied to a forever card. You just have to figure out which one. Don't worry, we'll practice a lot more. And like in section 5.3, we're going to see an FRQ even at the end of the notes, which we might get to today and we might not until tomorrow. But guys, once again, 5.3 is not a long section. And only sections 5.3 are the ones that we are doing from chapter 5. So therefore, it's been on the calendar for a while, but we do have a test this Thursday. Now, depending, it might get moved to Friday, just kind of seeing how today goes because we are a little bit behind. We are going to be doing some more key practice tomorrow as far as just kind of seeing, like Sarah said, this is a very practical chapter as far as it's a culmination of a lot of different stuff that we've done. And yet, multiple choice questions you guys can see with slope fields especially, or FRQs you can see with slope fields and with differential equations. All right, do you guys see there's an example up there that we're supposed to hit before we keep going? It's in red. What's the wording say? Do you think we're solving for a particular solution or a general solution? Why particular?
Because they give us a point.
You have a point. You have an initial condition. So we need to solve for C, yeah? We need to solve for C. Now, kiddos, hold on. We've seen harder differential equations like this at the beginning of section 5.2. How do we start taking this integral? No. Rewrite. Good. So you guys get ahead of me a little bit, those of you that know what to do. Those of you that know what to do, get ahead just a little bit. But the rest of you guys, here we go. Let's go ahead and change y prime to be dy dx. Let's go ahead and change y prime to be dy dx. Let's go ahead and multiply both sides by dx, right? Because we gotta get our bookends in place where they're supposed to be. But my question is, can we take an integral as is right now, both sides?
No, but you can multiply them 2y.
Exactly. I actually have options. But the long story short, can we at least see the problem? The problem is that y. That y would be bookended inside an integral and a dx, and is that allowed? No. So therefore, I do need to move that to the other side. Could we move the 2 and the y? And the answer is definitely yes. Could we move just the y? Yeah. The answer is also yes. I'm going to go ahead and move just the y. Doesn't mean that others of you that move the 2y will be wrong. My answer is just going to look a little different. Because what's going to be left over here is going to be 5 halves x dx. Can anybody give me a reason as to why I might just use or move the y, not the 2 also? Yeah. Because we have to get y by itself at the end, right? So then in order to avoid that dilemma, we could just move the y and not the 2 as well. Good. Now we just integrate both sides, right? Like implicit differentiation to derive both sides, but now? Oh, you like the 2? Okay. So let's just see what's going to happen with mine, because I'll just have 1/2 y squared equals 5 halves x squared over 2 plus c. I mean, we're going to end up at the same place, right, guys? Because wouldn't we multiply both sides by 2? Yeah, so either way you do it, you're totally right. Some of you, it wasn't totally bad. I was just trying to show you the idea that you don't have to move everything with the y. You could just move the y itself sometimes. But we do end up with, that's going to cancel out with one of the 2's. Y squared equals 5 halves. You still have a half.
Yeah.
X squared plus c. That's true. You could. You have 2 options. One option is to take your 0 and 4 and plug in right now and solve for c, then get y by itself. The other option is to get y by itself, then plug in the clue and be done. Okay? I'm going to go ahead and choose the second option because that's what we've been doing most frequently in the sense of getting y by itself. I also want you to see something with that plus or minus square root. So I have 5/2 x squared plus c. Right? Plus or minus square root? Then we go ahead and plug in. So we end up with 4 is equal to plus or minus square root of 5/2 times 0. Now here's my question. If y of 0 equals a positive 4, what would be the appropriate plus or minus for us to choose? Positive. I need to choose positive because I need the y to be positive. What if y of 0 equaled negative 4? I would need to choose the negative root. A root by itself is automatically positive, and so if I need it to be negative, I'll have to change it, but otherwise I'll keep it the same. Remember the wind flow in Iraq and Iran, Saudi Arabia, and all that jazz? Depending on where you choose, you might follow a different flow. So in this case, we had to say, this is the point that you're telling me to start with, so let's choose the positive. So let's choose the positive. So we can go ahead and solve for c. That's just going to be 0, right, guys? Square both sides. c is equal to? 16. So my final? Oh, I have to square both sides?
Both sides. Sarah,
oh, be nice. Then I end up with y is equal to not plus or minus. That's not for this clue. Just positive square root of 5/2 x squared plus 16. Some of you guys, I think, Tyler, was it you that you were like, wait, can you just plug in? If we had plugged in way back here, for those of you on the video, what we're talking about is right here. If we had plugged in 0, 4, we would have had to be careful with the negative, because if we had plugged in, we've gotten 16 equals 0 plus c, and we're like, sweet, c equals 16, but then we still would have had to get y by itself. So if you hadn't thought about it and just put the plus or minus, you could be in a bit of trouble, because this technically does not work until you take out the negative and choose the positive. So that's the dilemma. So typically I'm erasing all the green just for simplicity, but typically I like solving for y first, then getting c. That way you kind of don't accidentally forget to have it all nice and polished and perfect and ready to go at the end. But sometimes it is easier to solve for c earlier and just keep an eye out for the final solution. But the main idea of this entire section is something that we've actually already been doing. So maybe this is why the test will feel like it's coming up really quickly on Thursday. But with only sections 5.1, 5.2, and 5.3, 5.1 slope fields, and we did tons of practice on that. And you have extra FRQs in the notes packet if you want to practice more. 5.2 were word problems, but once again, 5.2 is not a huge topic for AP Calculus. It's just something I wanted you to see, and it will be on the test. 5.3, though, is huge, but we've already been preparing, because 5.3 says separation of variables. It's basically saying, what if there's a more complicated differential equation where you have to be moving stuff around? But guys, have we been moving stuff around already? Yeah. We need to get the y's on one side with the dy, get the x's on the other side with the dx, and then we integrate using all the rules that we know. So that's what was going on at the bottom. X terms need to be collected with the dx. We need to bookend any function in terms of x with the dx, and then we need to group together any function in terms of y with the dy. You're not allowed to divide by a dx in the sense of you're not allowed to have an integral with a divided by dx. It has to be times, has to be in line. Same thing with the dy. And what's inside can either be constants or x's, constants or y's for the bottom one. So if I was to give you something like this guy, what would you guys think of doing? Go ahead and write them down. Take a second. A moment or two. The AP would put this a little bit nicer. The AP would probably give you a point. I did not give you a point. So question, is it going to be particular or general? Good. It's going to be general, not particular. What would my advice be for where to start? Change y prime to dy dx. My advice for where to start would be change y prime to dy dx. Well, things with y's are allowed to be with y prime. But if you can move everything else but the y's, that'd probably be a good idea. You think you have to, yeah. Yeah, you can. You can. Like the long story short is that you realize it does need to move. So it could be first or it could be second, either way. So some people, I mean, Sarah's saying like, hey, the 2 plus x, I know that that can't stay where it is, so she's going to divide that first. I kind of like, just personally, I like writing dy dx first so I can kind of see where I'm at. And then I just always get dx to where he's meant to be because that's one of the most common mistakes I see kids do. So I automatically get the dx to be where he needs to be. And once the dx is set, once the dy is set, now I'm like, okay, let's rearrange the rest of it to be where I need it to be. Now I'm going to go ahead for simplicity's sake, just move the y, not the 3. Leave the 3, and then move the 2 plus x. Does that look pretty legal to you guys? Ah, I don't need my ln yet until I go to take the... But you're seeing where I'm going, right? Yes. Because 1 over y does integrate to be ln of absolute value of y, right? Now, struggle over here. This is where 5.3 is going to get tricky. You have to remember all the integration stuff from chapter 4b. U equals 2 plus x. What's du equal? 1 dx, right? Yeah. So couldn't I rewrite this just to be the integral of, pull out the 3, 1 over u du? Yeah. Oh. Okay, so it didn't turn out too bad. But every now and then, you guys know with u sub, there might be some extra constant that appears. But we are going to have 3 ln of 2 plus x plus c. Now, you guys see that we're supposed to do e for the ln, right? But here's the struggle. If we do e right this second, that's great over here. But the 3 is messing it all up. And we're going to have to do an illegal jump. So Austin's remembering, hey, wait, ln's, can't we move 3 up? Yeah. So ln of absolute value of y is equal to ln of absolute value of 2 plus x quantity cubed. Now I can do the e to both sides. Now careful, is this c being added outside of it all, or is it now trapped? It was added outside of it. It's trapped. Now wait. Think growth and decay, exponential growth and decay. When we have a plus c in a power, how can we change it? We can change it to be e to the c, and e to the c changes to be c times. Remember it. Good question. The absolute value is going to stay on both sides for right now. Wait. Where'd the... Oh, that's right. E and ln do what? Cancel out. Good. In case you guys are like, wait, what? Okay, remember. E to the properties of exponents. When you have addition and exponents, it's multiplication of like bases. And this guy, e to the, if you want to call him C1, you can. C1 will become C2. He becomes his own arbitrary constant. Now, question. If this is absolute value, he's always going to be positive, yeah? Okay. And then if that's absolute value, he's always going to be positive. Okay, so now it's true. If I take away this absolute value, could this y theoretically be positive or negative? Yeah, they could. Well, then how am I going to get that negative? I could maybe change this guy to be a negative. I could put a little plus or minus c, saying that, okay, when I take away an absolute value, I do the plus or, sorry, when I do the absolute value, I do a little plus or minus That could be one way of thinking about it. But the other way of thinking about it, well, here's the struggle with the 2 plus x cubed. If I take away both absolute values, now neither one is guaranteed to be positive, so I kind of mess it all up. If I take away just one, I'm like, okay, well, this guy could have come from a positive or negative. It's legal for y to be positive or negative and still keep everything positive. But what I'm going to say is, hey, positive or negative times c, that's going to get absorbed, and whatever initial condition they give us will make it right. So you could have put the plus or minus, but kind of like how e to the c becomes a c, we could also say, hey, this little plus or minus c2 can become a c3, if you want to put it like that. But the AP doesn't need us to do little subscripts on all of our little c's. It's okay for them. They don't mind for us if we just show what's going on. Kiddos, tomorrow's class on the calendar says AP practice. Ooh, I wonder why. Because we're done with 5.3. The idea of 5.3 is you just have to make it legal. Like on these two, we have two different ones. Is it legal right now to multiply by dx and integrate? No. Wait, why are we even integrating? Oh, A says find a solution to. We have to actually solve it. But if we rearrange it, could we then integrate? Yes. Or this next one, can we just multiply by dx and integrate? No, but could we rearrange it and then integrate? Yes. Now, there are different parts, so maybe not every single one is asking us for the exact same thing. But we're going to do AP practice tomorrow with 2 different FRQs, but long story short, do you guys need the AP practice to work on homework? No. So have 5.2 done as well as you can. Bring it in tomorrow. We'll grade 5.2, but 5.3, to be honest, you can do that tonight too. Work on 5.3. Come in tomorrow with questions on both. It's chapel day. Bye, guys.